Hi guys, welcome to Matsi with me, Miss Resi, your teacher for today. So today we're going to discuss about hyperbola. Previously in our discussion on conic sections, we described hyperbola as this one. If the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the knobs of the cone to form an open curve called a hyperbola, which has two disjoint curves. Now let's have the definition of the hyperbola. It is a set of points on the coordinate plane such that the absolute value of the difference of the distance of any point from two fixed points is constant. To analyze this further, we need the different parts of the hyperbola. Let's have the first part. These two fixed points together are called the foci of the hyperbola. So let's draw. The midpoint of the line segment joining the foci is called the center of the hyperbola. So let's draw. Hyperbola is symmetric about this line through the foci. It's called the transverse axis of the hyperbola. So let's draw. These points at which the transverse axis intersects the hyperbola are called the vertices of the hyperbola. So let's draw. A line passes through the center and is perpendicular to the transverse axis is called the conjugate axis of the hyperbola. So let's draw. So this should be perpendicular or forming 90 degrees to the transverse axis. And lastly, if we extend the hyperbola indefinitely, the arms of its two curves keep approaching these straight lines and never touches them. They are called the asymptotes of the hyperbola. So let's draw. Notice that the two branches of the hyperbola are contained inside the asymptotes. We can see that this orientation of the hyperbola satisfies these conditions. Here the foci are on the x-axis, except this is only one other possible orientation of the hyperbola satisfying these conditions. And that is this. A while ago, the foci is around the x-axis. This time, the foci is along the y-axis. So we will only consider these two orientation as the equation of the hyperbola is simplest for them. Now let's have the equation of the hyperbola. So let's look at this hyperbola on the screen with foci f sub 1 and f sub 2 for point P. the difference will be equal to the length of the transverse axis, that is 2a. For the points on the hyperbola, the difference of the distances from the foci is constant. This constant difference is equal to the length of the transverse axis, that is 2a. Here, by difference, we mean that the absolute value of the difference is the distance of the point from the farther focus minus its distance from the closer focus. So observe that we draw the coordinate axis such that the x-axis is along the transverse axis and the center is at the origin. We take the distance between the center and the one of its foci. So the coordinates of the foci are this. Consider this point P on the hyperbola. As we saw, this difference is equal to 2a. To find the equation of the hyperbola, we have to find these distances. Using the distance formula, we could find these distances. The distance between point P to point F sub 1 will be this. And distance between point P to point F sub 2 will be this. Now simplifying this will give us the equation of the hyperbola. Let's quickly have a look at some important steps during the simplification of this equation. First, we'll transpose this term to the right hand side. Now, we square both the sides. We get this. Upon simplification of this, we will get this. Again, we will square both the sides and simplify. And then we get this. Notice that this term c squared minus a squared is familiar with the Pythagorean theorem. Through this, we define the length of the conjugate axis as 2 times b. Now here we can substitute b squared instead of this term. We will get this equation. So we see that if a point on the hyperbola, then its coordinates will satisfy this equation. Here, A is the distance of the center from one of its vertices. Or we can say that it's half of the length of the transverse axis. And B here is half of the length of the conjugate axis. It's defined as the square root of the difference between the squares C and A. One thing to note here is that we took the point P to be on the right side curve of the hyperbola. But if we take the point P on the left side curve, we will arrive at the same equation.